For this rational function, we'd like to start off by factoring it as much as possible. So our numerator factors as x minus 5 times x plus 1. Our denominator, of course, doesn't factor at all since it's already a linear factor. There are no common factors, so we don't need to worry about reducing this. For our x-intercepts, we get the zeros of the numerator. So that gives us x equals 5, which has a multiplicity of 1, and x equals negative 1, again with the multiplicity of 1. To write those actually as x-intercepts, write them as points, 5, 0, and negative 1, 0. For our y-intercept, we just plug 0 into the function, f of 0, which equals negative 5 over a positive 3. So negative 5/3 as a point, that's 0, comma, negative 5/3. Vertical asymptotes are the zeros of the denominator of our reduced form. So here we've got the x plus 3, set that equal to 0, and we get x equals negative 3. And that has a multiplicity of 1 as well. For horizontal or oblique asymptotes, we compare the degrees of the numerator and denominator. And the degree in the numerator is 2, and in the denominator is 1. When the numerator has a degree that is exactly 1 more than the denominator, we know that we have an oblique asymptote, or a slant asymptote. And we can do long division or synthetic division, if applicable, to get the quotient, which is the slant asymptote. So I'll go ahead and do synthetic division here. Our numerator coefficients are 1, negative 4, and negative 5. And dividing by x plus 3, which has a 0 of negative 3. Bring the 1 down, multiply by negative 3, add, multiply, and add. And so this tells us our quotient is x minus 7, and then our remainder is our 16. And for the oblique asymptote, it's just that quotient. So we have y equals x minus 7 for our oblique asymptote. So let's go ahead and start sketching this. We've got our x-intercept at 5 and negative 1. We've got our y-intercept at 0 and negative 5/3. We've got our vertical asymptote at x equals negative 3. And we've got our oblique asymptote of y equals x minus 7. So that's, I'm going to go ahead and just draw a perfect line, and then I can turn it into a dashed line. So we can see then that our function, we've got to follow our asymptotes. Each of our x-intercepts has a multiplicity of 1. So we're just going to cross through the axis there. So to follow while passing through those points, it'll look something like this. And then on the left side of the graph, we cannot cross this axis. So we can't be coming up and then come down to follow the asymptote. So we're going to actually be down below. And well, my asymptotes did not extend, so let me go ahead and do that. And then we can sketch kind of a curve there that follows the asymptotes. So there's the rough sketch of this function.